Hello, in this video we are going to go over the solution of the problem 509, Fibonacci number. Fibonacci series is something like this one, that summation of every two elements will be the third element. For example, summation of 0 and 1 is 1, summation of 1 and 1 is 2, summation of 2 and 3 is 5. Okay, so the first element is 0, the second one is 1, and for n greater than 1, we can use this formula. Okay, let's start writing the code. We are going to write the function fib, and it has one input, n, and we are going to see what is the Fibonacci number at n. For example, we saw that Fibonacci of 5 is 5. It's a 0, 1, 2, 3, 4, 5. So, or Fibonacci of 6 is 8. Okay, so we could say if n equals 0, we are going to return 0. Or if n equals 1 or n equals 2, the value is 1. We are going to create that Fibonacci series, and we call it fib series. And I need to initialize that with some non-elements. And the length of this list will be n plus 1. Because we also have the index 0, so I need n plus 1 elements in it. Okay, let's print this. See, that's something like this. It's n plus 1 non-list. Okay. So for the first element, we know that that should be 0, because Fibonacci of 0 is 0. The second element is 1. Fibonacci of 1 is 1. Fibonacci of 2 is also 1. Let me print that again. Okay, we have 0, 1, 1. Now we are going to create the rest of that. Say for I in range of 3 n plus 1. Why 3? Because we already have 0, 1, 2 defined. Now I'm going to start at index 3. And we are going to go all the way to the index n. And then we say Fibonacci series of I equals Fibonacci series of I minus 2 plus Fibonacci series of I minus 1. We are following this formula. Okay. And at the end, I'm just gonna return Fibonacci series and also Fibonacci series, the last element of that, which is index n. Okay, let's run it. This is the Fibonacci series, and this is the last element 5. So Fibonacci of n is 5. This is what we expected to see here. Okay. Now let's talk about time and space complexities. For the time complexity, we are visiting all of the elements only once, and as the result, the time complexity is order of n. For the space complexity, we created this fib series that has n plus 1 spots. As the result, the space complexity is also order of n. In problem 509, they asked you to just find the value of the Fibonacci number at n. So you are just interested to find this term and not the fib series. And as a result, we can solve this problem in a way that we could have a space complexity of order of 1. For doing that, we just need to modify this code. And let's do that. So instead of fib series, I'm going to define a variable. I call it first equals 1. Instead of second index of fib series, I can define another variable. I call it second equals 1. Inside the for loop, instead of that statement of updates, I can now have a third variable and call it third equals first plus second. And now I can update first by moving that one forward and updating second as third. Okay. And now at the end, I just need to return third. Okay, let's run it. We get the value 5. As a result, we can have this code that could have a space complexity of 1. Okay, this is the solution of the problem 509, and thank you so much again for watching this video.